Blue Origin's New Glenn rocket and SpaceX Starship both had test launches. What does it mean for them and the rest of the industry?
Well, let's just get right into it here. The first launch of the New Glenn, which is the rocket that came from Blue Origin, that's the Jeff Bezos company. This has been a long time coming. People have been waiting for it for quite a while because they actually started before SpaceX and they just got something to orbit now, finally, for the first time. And it was actually pretty impressive in a way. I mean, after all these years of delay, to actually achieve orbit on the very first try is quite an accomplishment. Not many rockets accomplished that. And even more interesting, they went all the way to medium Earth orbit. They didn't just settle for barely making it up to the lowest possible orbits, the low Earth orbits. It's an elliptical orbit, about 1,500 miles by about 12,000 miles. So it covers pretty much a very large section of that. They're aiming their market at that, not just low Earth orbit. So that's important to them. So it was a success. It wasn't 100% success because they had kind of a secondary goal. And they said in the beginning, well, we probably can't do this, but we're going to try to land our booster on a barge on the very first try. And that did not succeed. But they tempered expectations on that. They didn't necessarily expect that they'd be able to. And this is interesting because this is their very first flight. To get qualified to launch national security things like spy satellites and that kind of thing, this actually counts as the first launch. Already their very first launch, they're starting their certification process. So this thing is really big. I'll show you some numbers and some pictures later on. Not as big as Starship. It's bigger than just about anything else except SLS and Starship. Launch picture, I should have highlighted. What I assume that is a time-lapse photograph where they're actually showing the second stage lighting up. That's kind of an interesting time-lapse photograph. This is another view taking off. People have commented in particular that the really nice blue flame, they get a nicer looking flame actually than other methane-fueled rockets have of late. Now, it also included something else. They called it a dummy payload, but it really is something that they're also trying to make a product out of, which is essentially a space tug. You can think of it as a small satellite, but it can also drag around other satellites. It's really part of its job. So it's an orbital transfer vehicle. They put it up there. They're not actually testing out moving that thing around, but their goal here is pretty much to accomplish what happens with the Falcon 9 launches, where they bundle together a whole bunch of satellites that all want to go to different orbits. They just shoot them up to one particular orbit, and then there's the little space tugs that take them to the other orbits they want to get to. And they want that part of the business as well, and that's part of what Pathfinder is all about. They can move around about 6,600 pounds is their goal. Partly funded by the Department of Defense. They had a lot of interest in doing this. Anyway, this whole test, dummy payload, so to speak, was about at least 40,000 pounds. The numbers vary depending on your source, but they give you that kind of an idea. That's a pretty substantial load. So for a first launch, again, quite good. I would say even the SpaceX early launches and Starship, they didn't have much of a payload at all. They actually put a real payload weight in there. So Space Tug is one of the applications. Try to capture some of that business that third parties are now getting. Also, they're talking about other possible uses in space computing. We actually talked about this in one of our earlier sessions where people are talking about putting data centers up in space. You got solar power up in space. That's pretty straightforward. We've done that for years. But getting that power back to Earth, that's problematic. You got to convert it to microwaves. You lose a lot in the atmosphere. People worry it could be a weapon, all kinds of stuff that causes trouble with that. Whereas if you just put computers up there, they can do their computing thing quite happily. They only have to send back the results. So it's a lot easier than transmitting power to Earth. And I think they're aiming for some of that. So one thing about Blue Origin, they've been criticized pretty heavily in the past for just moving slowly. Part of it really came back to the top management outside of Jeff Bezos as the ultimate owner. They really came out of the older space companies, and they were just slow. And they actually had this coat of arms. I don't quite know why you need a coat of arms, but they had a coat of arms. It has turtles on it, kind of referencing the tortoise and the hare. And it has this Latin saying, which apparently means step by step ferociously. And everybody was always kind of joking, well, the step-by-step part, they got that down. Ferocious, not so much. Well, now maybe it actually is picking up. They did change the CEO out. They brought in somebody from Amazon who didn't have that much aerospace experience, but on the other hand, was considered to be a much better manager. And what people are saying, things are moving a lot more quickly now at Blue Origin. And now we're starting to see the result of admittedly years and years of work, but people are thinking that things are probably turning around. They may actually get to be a much more serious competitor. And of course, they've been criticized. Instead of actually building a rocket, they were just suing to get their place reserved for whenever the rockets were ready. They are actually competing in the sense that they have a lot of customers already, not just NASA, but Amazon's Project Kuiper, for instance. which will have thousands of satellites. They will be their ultimate customer. They just weren't ready for it. AST Space Mobile, we've talked about, that's the alternative to the SpaceX version of regular cell phone communication via satellite, and some of the telecom providers along with that, and national security launches. A lot of these people all want to have some solution other than SpaceX. Nobody really wants a monopoly, kind of a thing. So people are kind of rooting for a second player. People always assumed Blue Origin would be that. They just kind of lagged and had been kind of disappointing up until now. Now, I think they're finally proving that they may be really serious. One thing about them is their rocket, at least their first stage, is reusable. And that's a key to really having costs come down. Unlike all the other competitors that are out there, like Vulcan from United Launch Alliance, the Ariane 6 out of Europe, the H3 from Japan, they're all just kind of traditional rockets. They just are thrown away. And, there's always that old analogy of, well, if you had to throw away the airplane every time you flew to Tokyo, it would cost you a lot to get to Tokyo. And so they will be able to address that. Now, they didn't succeed in catching that booster on the very first try, but then again, neither has anybody else. Not SpaceX, not the Chinese, who are also trying to catch up in this area. Just to give you an idea on the relative sizes, we talk about big. On the far right-hand side, there's Starship, and it does kind of dwarf everything else. Don't get out a ruler and actually try to measure that. These are kind of eyeballed. I didn't actually calculate down to the millimeter here. Blue Origin is the next one there. I don't actually show SLS in this particular chart, but it's like Blue Origin. And then on down, this is a Terran R, which may or may not ever come into existence. It actually is pretty big. The one to beat right now is the Falcon 9 from SpaceX, that one there in the middle. And there's the whole cluster of them. They're really about the same size as the Falcon 9. There's the Ariane 6, which is the new European one. There's the Vulcan out of the United Launch Alliance. There's a smaller one. That's actually a China one. That rocket there, it's called the ZQ-2. That one was the first rocket that made it to orbit with methane as a fuel. They beat everybody else, including SpaceX and Blue Origin. The Neutron, that's a product of Rocket Lab. It may not launch this year, but it's getting closer.
The question arose, is the Chinese ZQ-2 reusable?
No, but their next version is, and they're working pretty hard on that. China's kind of in this big turmoil right now. They have like 10 or 12 different things going on. One by one, they will drop out, and they're all trying all the different tricks and techniques. And so they try every different thing. They try different fuels. They try solid boosters or not. They try reusability or not. But this is one of the leading ones that people expect to actually make it with a reusable rocket pretty soon. Their big heavy lift vehicle with a Long March something or other name will also be eventually reusable, but they haven't really demonstrated that yet. But they're coming along. Okay, the data, you can get it out of Wikipedia for the most part, but not all of it. Especially when you get to things like launch cost. Well, that really depends on who you ask and what special pricing one company or another gave. But it gives you the idea that roughly there's a spectrum here essentially ordered more or less on low Earth orbit capability. That is, how much can you lift to low Earth orbit in thousands of pounds? And there's typically ranges on these things because there's configuration differences. I mean, for instance, the Ariane 6 has some flexibility. You can have 2 or 4 solid boosters. So if you want to put a lot up there, you add more boosters to it. Vulcan Centaur, that one in particular, you can have none or 2, 4, or 6. So you have a lot of flexibility there. All the reusable ones go for no. They don't even have solid boosters. That's pretty bad from an environmental standpoint. It definitely is not reusable. You cannot reuse a solid booster. So they're not really probably the end result in the future, but it's certainly a traditional way that people have attacked getting into space. We put in things here like who has reusable first stages. Actually, nothing except Starship yet is doing a reusable stage 2. Well, of course, theirs isn't actually reusable yet. But at least that's their goal. And that's one of the problems here is talking about what version.
There was a question on the status of the Vulcan rocket.
It works. It uses the engines actually from Blue Origin. They have a lot of launches scheduled.
Their first launch was successful, and their second launch was mostly successful.
They had some trouble with the booster. It didn't really quite perform like it should have. But I think that was part of the certification testing. I think that was considered a pass because they did achieve orbit, even though the booster didn't really behave the way it was supposed to. People think it'll come through, and then the Centaur, that it's been modified, but it's been around. That thing's kind of been around for a long time.
A question came up on the Sierra Nevada spaceplane called the Dream Chaser that is scheduled to be launched on the Vulcan rocket this May. The schedule had been delayed partly because of delays in the Vulcan rocket, especially due to the Blue Origin main engines.
They're still on for this year. Well, I'm not sure Sierra Nevada was really ready either. So it's always a race as to who can fall behind the most first. So something. Yeah, that's been a challenge. But that's normal in the business. One thing you can say about people that build rockets and to build the things that go in rockets is they don't always deliver on time. So there's ranges on a lot of these numbers. One, because of like how many solid boosters you have, if you have them. In the case of the reusable ones, it gets really complicated with Falcon, for instance, because you have the case of, well, are you completely reusing your first stage booster? Even there, are you returning it all the way to the launch site, which takes the most energy, or are you just dropping it down on a barge in the ocean, which means it doesn't have to come back as far. Typically, you're launching to the east, take advantage of the Earth's rotation, like from Florida, and you can come all the way back to Florida. That takes more fuel, so you have less available for payload. Whereas if you go and just come back in the ocean somewhere, it takes less. Yeah.
Did new Glenn actually carry Orion to orbit?
I don't know. The numbers get a little more iffy when you get to these. Like the GTO is geosynchronous transfer orbit. That's not getting to a geo orbit. That's getting to the orbit that'll take you there, and then on the assumption that the satellite or whatever gets you there. And then the translunar injection, TLI. I mean, that says it'll get you to an orbit that will take you so that you can actually get to the moon. It's not the actual moon orbit. Well, it also depends on what else is in that payload. And I mean, that shows up when I get to the moon launches that are coming up. There's two of them that are being launched. There were two of them put on one Falcon 9, both of them going to land on the moon. But Falcon 9 isn't taking him to the moon. It's just taking him actually just to an Earth orbit, and they're getting there on their own after that. So it's pretty hard to answer those kind of questions. And then it depends on where. Like if you're going to the Gateway, well, that when they have that, that's a really hard, that's harder to get to.
During the meeting, no one looked up the mass of the Orion spacecraft. Checking later, the combined Orion crew module and service module mass is over 58,000 pounds, so New Glenn could get Orion to low Earth orbit or perhaps medium Earth orbit, but not above that.
Now with Starship, you're talking Block 2, that's the current version of the upper stage, which failed completely. And we're still on Block 1 for the boosters, so you don't know how good these numbers are anyway. But so far, it looks like Starship is still going to by far have the most capacity for any of these orbits. Vulcan and Ariane 6, they have hydrogen second stages. You get a higher velocity coming out of the exhaust, you do a little better. So the Vulcan and Ariane 6 look better than you might think for the higher energy orbits. And that's partly what they're selling it on. They're going to go for a lot of the national defense kind of market. Now, of course, most of the business is launching big constellations of communication satellites to low Earth orbit. Big thing down here to look at is cost. There's kind of a range on all these, again, depending on whether you're returning to launch site or throwing away the rocket and that kind of stuff. Starship really stands out. They're guessing maybe they can do that for like $100 million for a launch, but it has a whole lot more capacity than the others. But that's in expendable mode. Now, once they really get reusability going, especially for those stages, presumably that's going to come down. But that's pretty speculative. I wouldn't take those numbers too seriously right now. But one we do know pretty well is SLS. That's the one that stands out. The units are billions rather than hundreds of millions in the case of SLS for one launch, 2.5 to 4 billion, depending on which audit the government happens to have done most recently. I mean, that's just so far off the charts. That's why it never had a commercial future. They had other reasons for being there.
And there's a very surprising Boeing employee meeting that happened on Friday.
I'd say a very unsurprising meeting.
Oh, maybe unsurprising.
Yeah, to me, I mean, it's completely unsurprising.
Can you say a few more words about the Boeing meeting?
Yeah, so Boeing had a meeting of their workforce and said that there's a chance that SLS maybe cancel, is essentially what they had said. Nothing specific.
They're giving a warning that politically it's not as well supported as it used to be. And it came down to being a political issue more than anything else at this point.
What's your feel? Is it a 50-50, 75% chance it's going to cancel?
I would say let the new NASA administrator get confirmed, give him a couple of months, and then we'll have a better direction on where things are going.
Yeah. I think an awful lot of people assume SLS was going to die, but maybe not this soon. Mainly because it was a jobs program created to keep the shuttle companies and employees employed. And so they dictated the technologies. And the natural way that NASA maintains support is they have facilities in every state. And literally for SLS, there are parts of the SLS rocket that are built in every single state. And as a result, every state has some incentive to keep a piece of it because they have some people employed doing it. It's a great strategy for maintaining your agency, but it's not too good for efficiency, and you kind of end up with results like that. A lot of people kind of assumed you'd probably make it through Artemis 3 before it actually would get canceled. Artemis 3 is the one that would actually put people on the ground. Just because that way, whoever's in charge can still sort of take credit for there being a lunar landing, even though there wasn't a future in that particular path to space. There was a dead-end path, but nonetheless, it was the program that there was. And, there was no alternative at the time it was started. And even now, I mean, you don't have a working Starship. It is part of the Artemis program, though. So if it doesn't work, that's what's supposed to take you down to the moon and back up. So if that doesn't work, actually, Artemis, the lunar mission, doesn't last anyway. So we're in this awkward position right now where most people kind of assume that, SLS can't be the future path for getting to space just because of cost. But when do you make that transition? A lot of the former politicians that were strong supporters of it, like Shelby of Alabama, they made sure that it stayed in place. And then you had Bill Nelson, who was one of the fathers of SLS in a way. He was the head of NASA there. And he actually ordered like the next 12 solid boosters. Each of those boosters, para boosters, for one flight cost $500 million. And he ordered way, way ahead on that, far ahead. So he was sort of gambling one way or another. He wanted to keep us committed to that. That was the strategy there. Ultimately, if the Senate still insists on maintaining SLS because they like the jobs in their districts, it may continue for quite a while. So you can't tell. And it's dangerous because everything gets so political in this stuff. But it's been kind of bipartisan. There are an awful lot of people who really don't like SLS, except for the people that are directly involved in it. The people that are directly paid by those programs. If you work for Boeing, obviously you're much in favor of it. Okay, moving on here. So we were talking about Starship a little bit. Of course, they had a test which had a spectacular success and a spectacular failure, all in the same test. And that's kind of represented in those pictures there. On the right-hand side, that's the pieces of stage 2 coming down over the Turks and Caicos Islands.
Which helped to improve my geographic knowledge of the Caribbean. I had not heard of that island before.
I had to go look at a map. I knew it was down there somewhere, but yeah.
Where is it for the rest of it?
I can't describe it as well as Google Maps, so
as you fly east, kind of threading your way between Cuba and the U.S., it's a little bit past that somewhere in there because it was on that flight path. They have a very narrow flight path they have to stick to, mainly to avoid dropping stuff on Cuba. We ended up paying a lot of money to Cuba. I mentioned this in the story a long, long time ago. We paid for a couple of Cuban cows. It might have been the 60s, maybe the 50s, I don't know. They had a point, though. We dropped debris on them, and we've been very sensitive about trying not to do that ever since.
And luckily, this time, I think it was only confirmed report was unoccupied cars.
All right, so Flight Test 7, January 16th. This was still suborbital. That was the plan. They didn't go beyond that. As I said, it was the newer version of the upper stage. They refer to that as ship. That's Block 2 in aerospace terms. Block 1 was still the older style boosters. They're still using just the Raptor 2 engines. They have these Raptor 3s they talked about, which are much more powerful, but they're not actually putting them in these tests yet. The booster returned to the launch site, as shown on that picture on the right-hand side there. They're pretty much the same as Test 5. Actually, if you watched it, it was smoother. I'd say they controlled it better. I mean, it really just came in really, really nicely and not a lot of overshoot and vibration and that kind of stuff. They really did a good job on that. They did have a problem along the way. One engine didn't restart. In the overall process, the second stage launches off. The booster has to turn around, so it has to fire some engines and slow itself down and start heading back to launch. One of the engines didn't restart. And what's interesting is that then they coast for a while, and then they absorb a lot of heat. And then when it gets close to actual landing time, they have to fire them again. Well, that engine then finally did restart. So whatever they had was some kind of a temporary problem, like a freezing in a fuel line or, that kind of a thing. I don't know that they have an explanation for it yet. But anyway, it didn't matter that much. They had enough spare power available. Other thing on this particular booster test was they did reuse one engine that came out of Flight Test 5. So they're starting working on, can we reuse the engines at least? And it was in the outer ring. There's multiple engines there, so it's in the outer ring, meaning that wasn't even used at launch. So the one that failed was not the reused one. It was a different one. So anyway, that was the successful part, but of course there's this other part, and that's as shown on the right-hand side here. The upper stage engine started to fail. And there was a fire, and that was apparently visible on some of the TV cameras. And we were looking at some of the fins in the gap. You could see flame in there. I mean, there was actually flames going on inside the vessel. The fire started. One by one, the engines were failing, and finally the ship actually blew up, or RUD, Rapid Unscheduled Disassembly, as they like to say. But it blew up. And again, that's kind of what it looked like. Probable cause was a propellant leak, is what they said. Now, where, I don't know that they know that, because they had just completely redesigned and rebuilt how the propellants are handled, and there's extra insulation and all this. It was a new vessel, so we don't know. This was quite visible. I mean, that's why people were taking pictures of it. Aviation was disrupted. People were warned, but they went outside of the official area. Normally, an area gets declared as a hazardous zone when you have almost any kind of a rocket flight like this. And some of that debris started falling outside of it. And so that disrupted aviation for at least a couple of hours. Scared quite a few people. And debris fell outside of the hazard zones. Most of it washed up on Island Beach, if people found it anyway. I think not all that much dropped directly on land, but there was some. This did drive more complaints than normal. Reminder that we really got to be careful, try not to let this happen. But anyway, this was the first test of the version 2. So they didn't really get a chance to do a lot of the tests for the upper stage that they hoped to. All those things depended on deploying the satellites, for instance, when they are launching Starlink satellites or something. They wanted to start practicing that. They want to do some reentry experiments to start figuring out, can you start to put the little hooks on the outside without melting them off so that you can catch it, the mechazola, the chopstick things. So they couldn't get to any of that. So they didn't get much data on that. Okay, upcoming launches, we talked about this last time, so I'll just highlight the changes. We still have Intuitive Machines coming up with their lunar lander. That may get there before the Japanese one does, even though it hasn't been launched yet. Rocket Lab, remember we talked about that project going to Venus, a private mission to Venus. It turns out that's gotten delayed. I haven't found any information on why. It doesn't show up on anybody's website yet that I found, but apparently it has been delayed. And Amazon's Project Kuiper, they're still expecting to do their first launch pretty soon here. The other one that's been delayed is the vast space station. That one has been delayed back to 2026. Originally, they were talking about it launching maybe this year, and I think that was probably premature. The other ones there really haven't changed. Okay, that's it. Oh, right on time. Yeah. Thank you.
Other space-related videos or slide presentations by me are available at the link shown here. That includes a list of videos at my YouTube channel, so you can view them or subscribe for notifications about future videos. These presentations are mostly made as part of the meetings of National Space Society's North Houston chapter, and the link to that is shown. Topics like these are presented as part of a monthly news segment, and there are also lots of other interesting speakers and open discussions. You can attend in person or online via Zoom. Come join us.